16.2 Solving exponential functions. We've been working on exponential and log functions, so we should know that they are inverses of one another. When I'm going to solve exponentials, my first job is to isolate the base, and remember the base has an exponent, so the base is whatever is attached to that exponent. We're going to rewrite it into log form because that's the inverse of exponentials. And then we're going to check for extraneous solutions. Now, this is a little bit different on exponentials, so we're going to look at that and make sure that we understand with our calculator. On this problem, 5 to the x power minus 4 equals 7. I'm going to isolate the base. My base is 5. It has the exponent. So I'm going to add 4 to both sides. We've got 5 to the x equals 11. Now the problem is that I know 5 to the 1 power is 5, and 5 squared, or 5 to the second, is 25. Neither of those is 11. But 11 falls somewhere in between. That is why we're going to rewrite into log form. So we're going to go log base 5. I don't know why I wrote that. I'm so sorry. Log base 5, because your base maybe stays your base. So log base 5. I'm going to isolate the exponent, so 11 is my argument. My calculator is going to do that work for me, so I'm going to go, oops, not there, math, up arrow, log base of 5, log base 5 of 11. I'm going to round, so x is about 1.49. Why do I round like that? I'm going to round to the hundredths. 8 is followed by a 9, so we round up. When I check this in my calculator, I'm going to be close, but I'm not going to be exact because I rounded my answer. So when we go to y equals, we're going to write 5 raised to the x minus 4. 7 goes into y2. When I go to the table, oh, I got some crazy decimals in here, but I need 1.49. So I'm going to go second window, 1.49. And notice that I'm at 7.00, so that's about 7, and at 7. So that should be correct. Again, because we rounded a decimal, we're not going to get exact, but it is very close to 7, so my answers match as close as possible because I rounded. Second problem, to isolate the base is 6. That means that the base is already isolated because there's nothing else here. So my job is to go to rewriting. Log base 6, isolate your exponent. That means 12 is your argument. So I'm going to say, get all that out, math, up arrow, log base of 6 of 12. When I answer this, I'm not ready for that to be my final answer because I still need to divide by 3. So I'm going to do this, 1.3 dot 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 equals 3x. Those dots mean I have not rounded yet. The answer's in my calculator. I'm leaving it there. And I'm going to perform my last step, which is to divide by 3. So I'm going to hit divide by 3 in my calculator. Notice it says answer, so it's taken that decimal. So I'm going to say x is about 0.46. Okay. Again, when I go check this in my calculator, 6 raised to the 3x equals, so I go to the y2. The table's got the decimal from last time. I don't want it. I want this decimal, so I have to hit second window and type in 0.46. Notice that I'm at 11.8 and not quite 12, but that would round up to 12, and it's because I cut my decimal off. The more of the decimal I use, the closer this will be to 12. Okay? Really important that you understand we're rounding, so we're not going to get exact answers. The third example, we have got the base at 6, and I need to isolate it, so I've got to get rid of that 10 by adding. So I've got 6 to the 3x minus 9 equals 7. Negative 3 plus 10 is 7. So my base is isolated, so it is time to rewrite. Log base 6, isolate the exponent. Exponent always comes over of 7. So I'm going to say math up arrow to log base 6 of 7. So when I write this, I'm going to say 1.08 dot 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 dot. I'm not cutting it off because I have a lot more work to do here. My next step would be to add 9 to both sides. So notice that I put in my calculator to keep the whole decimal, answer plus 9. So I would add 9, So I got 10.08 dot 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 equals 3x. And now my job is to divide both sides by 3. So now I'm going to be able to round. So I'm going to say divide by 3. Again, it kept the whole decimal. 3.36. In y equals, I'm going to type what I see on the left side. Then I come down, and on the right side I type this in. I want 3.36, so we're going to go second window, 3.36. Go back to the table. Notice that I'm very close to negative 3, and I'm at negative 3. Again, I rounded this off, so I'm not going to get exactly negative 3. So, problem number 4, I wrote over a little bit, sorry. My base is 10, so 90's got to go. Now, when you have an exponent to an exponent, you should know that those get multiplied, so you might as well put those together. That's 2 times x, 2x, and we should get 15. Again, we're ready to rewrite, but our log base 10 is understood. Isolate the exponent, so I never write a 10 here, by the way. I got a log button that is base 10 of 15. Okay, so again, I'll just push the log button. It's over on the far left here, log of 15, enter. But I've still got to divide by 2 here. Let me scooch this over. So we're going to divide by 2. And we're going to end up rounding, so I hit divided by 2. The 8 should be rounded up. When I go check this in my calculator, always, always, always type it exactly, oops, sorry, as you see it on your paper. No, I keep hitting the wrong thing. Notice that I put 10 in parentheses to the x raised to the 2 like it was on my paper, plus 90 equals 105. Always. When I go to check this, I want to go to the window and do 0.59. I'm at 105, really close. Again, I rounded, and 105. Okay? So, next problem. That one looks a little bit scary. The next one does. Notice that the base is 5. It's alone. So the first thing I'm going to do is I'm going to do log base 5. Isolate the exponent, always. That means 30 is going to drop in right here. So I got math, go up to log base 5 of 30. That is 2.11 dot 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 dot. Haven't finished yet, so I can't round it off. Leave it in the calculator. X and 4 are being divided, so the inverse would be to multiply. So I'm just going to hit times. So the answer times 4. So x is about 8.45. Okay. I can keep showing you these raised, oops, clear, 5 raised to alpha y equals x divided by 4. And we got 30. Again, we want to go to second window, 8.45. 29.9, which should be 30, and 30. So we're really close because we rounded. All right, now, you see this crazy E? It's about to do something a little bit weird, so make sure you watch closely on number 6. These were all very similar, but number 6 changes. Number 6, the base is E. So that means that 5 is not part of the base, so I've got to get rid of it first. This is easy math, you know that's 2. Alright, anytime you see the base of E, you have to take not a log. We're not logging anything. We're going to take natural log on both sides. Okay, and I want to show you something. If you do natural log in your calculator, and you do second natural log, and you put e to the 1 power, it's 1. So the natural log of e is going to equal 1. Okay, so what does that mean? That means over here I've got the natural log of 2. This becomes 1, so I just have the natural log of 2 of 4x. Okay, so let's put in our calculator natural log of 2. So we got 0.69 ... equals 4x. Okay, again, anytime I see e, I'm going to take the natural log on both sides, but the natural log of e is just going to go away. It's going to become 1, so I'm left with 4x. Now my next step is to divide by 4. So I'm going to say divided, so that my whole answer is divided by 4. So x is about 0.17. Now we can do a lot more than that, but for us we're rounding to the hundredths. So when we go to y equals, we're going to type 10, 5 second e to the 4x, right? Yep. We go to the table, I need to check this decimal. Okay, and again, that second window, so you can check it. 10 and 9.8, which would round me to 10. So I'm right there. So this is new and a little different when you see the E. So let's practice another one. Number 8. My job is to get the base alone. The base is E. So I got to divide out that 7. 6. 42 divided by 7 should be 6. Okay, so I've isolated the base. Now I have to rewrite in log form, and for e, I've got to do natural log e of 3x equals natural log of 6. I've got to take the natural log on both sides. Okay, the good news is natural log of e goes away. I've got 3x equals the natural log of 6. So let's put in natural log of 6. Move it over. So I've got 3x equals 1.79 ... And I need to divide by 3. X is about. So on my calculator's hit divided by 3. That's why I leave the decimal in there. 0.5. Oh no. The 9's going to round up because of the 7, so the 9's going to become 10, which makes this 6, 0. Okay, 6, 0. Again, we can check that in the calculator, but I've showed you enough, so hopefully we're okay there. The next problem, again, I need to isolate my base of e, so I'm going to subtract 5. I'm going to get 2 to the e, 2e to the x minus 1 equals 75. Now, you got to divide 75 by 2. Right here we got to divide by 2 because the base isn't alone, so we got e to the x minus 1 equals 37.5. We can get that. We did. When I see base e, I'm going natural log e, x minus 1, natural log on the other side, 37.5. Okay? So we're going to do natural log of 37.5. We got that decimal. We're going to add 1. So we get x is about 4.62. Again, I took the natural log and then I just added 1. You don't have to show me that. You can do it in the calculator and write your answer. Alright, so if you see a base of e, you've got to do natural log to both sides. Number 10. This is different again, but these can be pretty simple. Notice that the base is 3 and the base is 3. If the bases are equal, then I can set the exponents equal. The bases already match. So in order to work this problem, I would want to add the a. So I got 3a equals nothing. Nothing's over there. When you divide by 3, I hope you understand that nothing divided by 3 is still nothing. Now these you can easily check in the calculator. These will be exact. 3 raised to the 2x, you're going to have to make that an x. 3 raised to the negative x. I want to check 0, so let's go to the second window and type 0 in. You see how they match? So those are going to be exact, and that's wonderful. Okay? Number 11, again, you notice we've got 2 bases at 5. So if the bases are equal, I'm going to say 3 minus 2x equals negative x. Now, the x is alone here, so I'm just going to add the 2x to join it. So 3 equals x. Well, that was fast, right? 3 equals x. Uh-oh. I have 2 bases, but they're not the same. This is really important. 5 to the 3x plus 1 is going to stay. It's the smaller base. 25, think about this. If I do 5 squared, 5 times 5, that's 25. Okay, so what I'm doing is rewriting 25 into a base of 5. 5 times 5 is 25. Now my bases match. But this exponent that was already there has to multiply by the 2 that I've brought in. Again, 5 and 25 are not the same base, so I can rewrite 25 as 5 squared. Now I've got the same bases. So this side is 3x plus 1. This side I'm going to distribute the 2, so I've got 2x plus 2. The 2 that I brought in, because 5 squared, and I multiply it by the x plus 1 that was already there. So I'm going to subtract 2x, and then I'm going to subtract 1, so x equals 1. Alright, we're going to do one more of these. We've got 144 and 12. Those are not the same bases. They're not the same bases. But 12 is smaller, so I'm going to keep 12. And I know this, maybe you don't, but 12 to the second power is 144. So I'm going to say 12 to the second power, but I have to keep what I already had. So I've got to multiply my new exponent by what was already an exponent. So that means I'm going to get 4x plus 2 equals 5x minus 1. So for me, I'm going to subtract the 4x so I can keep the x's positive. And then I will add 1. So x is 3. And that is solving exponential equations.